Dear students, we are taking up the chapter Units and Measurements, which is the first chapter in your class 11 program. We have already covered, there are actually 5 topics, out of which we have already covered topic 1 and 2, and now we are taking up a very small topic which is significant. Let us see what is significant is. Data which is like this 00403.820. Now, supposing it's like this, then there is something called the leading zeros. What are leading zeros is the zeros before the very first non-zero digit. Which is a non-zero digit in this case? 4 is a very first non-zero digit. Therefore, before that 4, whichever comes here, which is now 0, are called as leading zeros. This could be full number 00403.820 is a decimal number, or it could be a full number, something like, let us say, 00403. Therefore, whatever it is, whether it is a integer number or a decimal number, whichever is the leading zeros are the ones which are occurring before the first non-zero. This now the first zeros are non-significant. All leading zeros are non-significant. Next, then whatever zeros are coming in between two non-zero digits, like in this case now this 0 is coming as in between, that is sandwiched between non-zero, they are all significant. Therefore, now trailing zeros in this particular number, now trailing zero is only this, that is the last zeros occurring after the non-zero digit. Which is the non-zero digit occurring last 2. If after 2, whichever zeros are occurring, now they can be significant or non-significant. Depends like this. Like for example, if it is a full number, like take for example 0030. Now in this case, this is now a trailing 0, and therefore it's a full number. Full number, that may integer trailing zeros are not significant, non-significant. Okay, therefore now this is what it is. Then what about the decimal number? Suppose the number happens to be like this 00403.080. Now here, now this is now sandwiched in between non-zero, therefore this will be significant definitely. Whereas now this is now a trailing 0, because after the last non-digit number, this 0 is occurring, which is a trailing 0. Now, but then if it is a decimal number, then the trailing zeros are significant. If it is a decimal number, trailing zeros are significant. Why is it? Because now, why did we say that the integer number trailing zeros? Why did we say that in this number now the trailing 0 is not significant? Because this can always be written as 403 into 10 power 1. Whereas in the case of a decimal number, this 820, if I just keep it like this, and then this 0 is a trailing 0, is non-significant or significant. Why do we say it is now significant? Because nobody says this 0.820 unless without a reason. What is the reason? Because accuracy of a measuring device can measure up to 1, 2, 3 decimal numbers, which means now the measuring instrument is accurate enough to give decimals up to 3 decimals. Therefore, if it happens to be the 0 as a last decimal, that is 0.820 is accuracy of the measurement, then He's got a reason why this particular 0 is occurring here. For all you know, if it happens to be, let's say, 0.823, then the accuracy is still 3 digits. After there is 3 decimals. Therefore, any zeros which are presented deliberately as trailing zeros are definitely significant. Therefore, this is the rule which is followed. Okay, let me just now summarize this. The leading zeros anywhere is not significant. Trailing zeros in integer number not significant. In the decimal number it is significant. Okay, some examples we'll just go through fast. 42.3 number of significant digits is 3. This 5.03 also is 3. 5.604 is 4 digits significant. Now 0.543 this now leading zero not significant, therefore it is only 3 digits. 0.045 now these two are leading zeros, therefore only 2 digits. Now this 0.006 this is only 1. Again, why we are calling it only 1? Because this number can be presented as 6 into 10 power minus 3. Therefore, it is only one significant digit. 4.330. No, there is a reason why in the decimal the trailing zeros is there. Therefore, it is also significant. Therefore, number of significant digits is 4. 433.00 for the same reason it is 5 significant digits. 400. No, because full number and then the trailing zeros not significant, therefore only 1. Fine. Now this is about the number of significant digits. What about then what are the rules for doing arithmetic with the significant data or non-significant digits? Is like this. The rules for arithmetic. Now there are now two kinds of rules. One is for addition or subtraction rule. This does not depend upon the number of significant digits, but only depend upon the number of decimals rule. Like what they are. Example you take now. Now 33.3 plus 3.11. We are now adding up these two numbers plus one more number 0.313. Now the rule for the result which you calculate just like any other this thing is normal method. You just take it up to the whatever is the decimal places which you are getting in the calculation. Keep it like this. Now we have to now decide about what is the rule is. Now we have to present the result as per the least number of decimals in the given three numbers. What are given three numbers? This 33.3 has got 1 decimal place, this 2 decimal place, this 3 decimal place. Which is the least number of decimal place? Only 1 decimal place. Therefore, you have to give the results up to 1 decimal place. Answer is 36.7. Next. Then this can be the same thing for the same rule for subtraction also. Now, then by the way, we have to now give the result 36.723 up to 1 decimal place. Then how do you round off is? Round off rule is pretty simple. Now you have to round off up to 1 decimal place. So if you look at the balance number 23, is it now less than 50? Because now it's a two-digit decimal, 23. Therefore, we have to see whether it is less than 50 or more than 50. Less than 50, therefore, now drop it and then put the 7 only. Okay. If it happens to be more than 50, let us say now 73, then you will actually round off to 36.8. Then the rule also says, suppose it is exactly 50. Suppose it doesn't happen with 36.750. Then what you do is, then because it is exactly what you are now dropping digits or 50 only, you have to now see the previous digit which is now 7. Now if it is odd, then you round off one place higher, that is 36.8 you have to become if it is odd. If it is even, then the rule, that is convention, actually it's a convention which is agreed by all scientific people. Therefore, we have to follow the convention which says if the previous digit, if the digits which are dropping is 50 or 500 or 5 etc., then if the previous digit is odd, then you have to round off to one higher. If it is even, we just keep it as it is. Suppose now this happens to be, let us say, 36.650, then and it should be rounded off to the first decimal only. Then we have to drop this 50 because it is exactly 50, and the previous digit is even. We have to round it off to only 36.6. Agreed? Okay. Therefore, no, that is a rule for the rounding off. So then we come to multiplication and then division. What is the rule is? Now we don't bother about the decimal number of decimals. We bother about the significant number of significant digits only. Now, like for example, suppose you now take the 142.06 multiplied by 0.023. Then you do the exact calculation, comes to 32.6738. Then we have to look into how many significant digits in the first number 5. What about this 2? Therefore, whichever is least is 2 only. Therefore, you round off the result only to the 2 significant digits, which are there now. 32 only has to be there. Now, then you see, because rounding off is 0.6738 to be dropped, it is more than 5,000. Therefore, you should now make it as 33. Understood? Therefore, now similar result for the division also. 51.028 into 1.31 comes to 66.84668. Therefore, now this is 3 significant digits, 5 significant digits. Therefore, keep it 3. Therefore, you now drop off up to this 4668. Therefore, you just keep this as a result. Now, the similar rule for division, 0.90 divided by 4.26, you get exact division gives this result. Then how many significant digits? Now this is now 2. This is now 3. Therefore keep it to only 2. 2 means 0.21 we must keep it. Understood? Okay, fine. Then we are given you from the past, we are asked questions of both NEET as well as JEE. We are given the question number. We are given you the PDF file also in our platform. You can find it. Then you practice the past asked question number what we are given. Question number 753 from the NEET PYQ as well as JEE PYQ we have given this, as well as advanced PYQ even this. Then as per our regular rule, NEET students should do the practice both from NEET as well as from JEE. And similarly, now JEE Main students should do both NEET as well as the JEE Main. JEE Advanced student should do both NEET as well as JEE Main. Plus, they should do the advanced also practice. So then with this, we will now take up next topic will be taken in the next session. Then the next topic will be vernier calipers as well as screw gauge. Thank you so very much.